Dear students, welcome to the video lecture of the recursion and an example to calculate the factorial of the given number using recursion. So what is a recursion first? Recursion first, a function, the process of a function which is calling itself is known as a recursion. The process of a function which is calling itself is known as a recursion. The function which call itself is called as a recursive function. Okay, the process is recursion. The function is called as a recursive function. So we are going to discuss the recursive function and an example how to calculate the factorial of the given number using recursion. So recursion is the process of repeating items in a self-similar way. Recursion is the process of repeating item in a self-similar way. If a program allows you to call a function inside the same function, then it is called as a recursive call of the function. Then it is called as a recursive call of the function. The function calling itself, okay, is known as a recursive function. That call is a recursive call. The process is known as a recursion. While using recursion, programmer needs to be careful to define an exit condition from the function. Otherwise, it will go into an infinite loop. Okay. While writing a recursive function, we have to properly write the exit condition. Otherwise, the function will call itself. Again, it will call itself. Again, it will call itself. It will go into infinite loop. The exit condition is very important. Recursive functions are very useful to solve many mathematical problems such as calculating the factorial of the given number, generating a Fibonacci series, and etc. So an example, okay, how it works. How does recursion work? We are having a function while it recurs. It won't return any value. Okay, it won't take any parameter. The function recurs calling itself. Okay, calling itself recurs. So this call is known as a recursive call. Okay, we are having a main function, return type as an integer. The main is calling recurs. First time what will happen? The main will call the function recurs. So after that, okay, when control come to this place, the recurs. Okay, so in this place, the main is a called function, main is a calling function, recurs is a called function. So in this place, what will happen? Recurse is calling itself again. That call is known as a recursive call. Okay. Again, what will happen? We call it again. Okay. For a function calling itself is known as a recursive function. So how long the call will go until the exit condition, okay, is satisfied. When the exit condition is satisfied, the call will come out from the innermost recursive call to next outer call, and next outer call until the control will come out. Then finally the control will return to the called function. So in this way only the recursion work. Now we are going to discuss about the computing factorial using recursive function. So how to compute a factorial? For example, I want to calculate the 5 factorial. So how to calculate it? 5 into 4 into 3 into 2 into 1. Okay, 5 into 4 is 20, 20 into 3 equal to 60, 60 into 2 equal to 120. How to calculate this? So from this number, okay, up to all the term up to the value 1. Okay, we have to calculate the multiplication. Then only we are able to get the factorial of the given number. If you take 4, 4 into 3 into 2 into 1. If you take a 10, 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So in this manner, from this number up to the term 1, okay, between the number and the value and the number 1, we have to calculate the product multiplication of the all the number. Okay, if you calculate it, then we can say that this is known as a factorial of the given number. So what is our objective? We have to calculate the factorial of the given number, okay, using recursive function. So how to calculate that? The factorial of 0 equal to 1. Okay, the factorial of 0 and factorial of 1 equal to 1. For other numbers, factorial of n, factorial is a function, n is a parameter. Okay, n is not a 0. Then we have to calculate n into factorial of n minus 1. In this place, what happens? Okay, the factorial of n, which is equal to n into factorial of n minus 1. So, when you want to calculate the factorial, we have to calculate the n into factorial of n minus 1. The function calling itself again, okay, but parameter value is 1 lesser than the actual n value. It will go, okay, the call will go until, okay, a return condition has met, and finally it will come out from the outer call, okay, to innermost call to the immediate outer call, next outer call, next outer call. When the control return to the called function, we used to get the value of the factorial of the n. So as a simple logic, n factorial equal to n star n minus 1 factorial. You want to calculate the 5 factorial. 5 factorial value equal to 5 into 4 factorial. So what is 4 factorial? 4 into 3 into 2 into 1. Okay. 4 into 3, 12, 12 into 2 equal 24 is a 4 factorial. 24 into 5 you calculate, you will get the 5 factorial. So that is the formula. Factorial of 0 equal to 1 as well as factorial of 1 also equal to 1. So we will see an example. Now I am giving n value is 4. How to calculate the factorial of 4? So it will call 4 into factorial of 3, n minus 1. Okay, n is 4, factorial of, okay, n minus 1 equal to 3. So what factorial of 3 will do? It will call n into factorial of n minus 1. So factorial of 3 equal to 4 into, okay, 3. Now 3 is n into factorial of 2. What factorial of 2 I have to calculate? 2 into factorial of 2 minus 1, 1. So 4 into 3, factorial of 2 equal to 2 into factorial of 1. Okay, then how to calculate factorial of 1? Okay, 1 into factorial of 1 minus 1, 0. Okay, 1 into factorial of 0. So here we are having 4 into 3 into 2 into 1. Okay, and into factorial of 0. So 0 factorial value equal to 1. So the factorial of 0 equal to 1. So 1 into 1, you are having 1 into 1. Okay, the multiplication of 1 into 1 equal to 1. Then, okay, the one value will return from the, okay, the call the factorial of 0. Okay, will return the value 1. Now it will calculate. Okay, in this step, it will calculate factorial of 2 into 1. Okay, it will return. Okay, it will return immediately. Okay, to the, okay, from we are calculating 2 into factorial of 1. Okay, it will return to the, okay, outer call now. So what I will calculate? Okay, 3 into factorial of 2. 3 into factorial of 2 equal to 2. Okay, 3 into 2. Okay, 3 into 2 equal to 6. Okay, the 6 is returned to the first call. That is 4 into 6, which is equal to 24. So a function which is calling repeatedly until the end condition has met. Once it's met, okay, the value is returned to the immediate outer call, next outer call, next outer call up to the outermost call. Okay, in this manner, we are able to calculate the factorial using recursion. Okay, so in the program wise, we are having a function factorial and we are having a parameter integer. When you pass 4, what it will do? It will check whether 4 greater than 1. If 4 is not greater than 1, okay, yes, then it will go to else part return 1. If 4 greater than 1, what will happen? It will go to if part. What will happen? 4 greater than 1. So which is 4 into factorial of, okay, 4 minus 1, which is equal to 3. So the function here calling itself again. Okay, again, what is the parameter? 3 is a parameter. Here what will happen? 3 greater than 1. Okay, 3 into factorial of 3 minus factorial of 3 into factorial of 3 minus 1 equal to 2. Okay, factorial after the function is calling itself again, next inner call. Okay, what it will do now? It will come to the place. It will check 2 greater than 1. Okay, return num into factorial of, okay, num minus 1. Okay, it will check. Okay, next call. Okay, it will check 1. Okay, 1 greater than 1 is false. So what is happening now? Now it is the, okay, it is the innermost call. It will return the value 1, return 1. Okay, the 1 will come to this place. It will call this, okay, this innermost call return the value 1 to the next outer call. Here it will calculate 2 into 1, factorial of factorial of 2 minus 1, which is equal to 1. I mean 1 equal to 1. Okay, it will return 2 into 1, return to the next outer call. Here it will calculate 3 into 2 and return the value, okay, to the first recursive call, the value of factorial of 3, okay, equal to, what is the value? 3 into 2 equal to 6. Then what will happen? 4 into 6 equal to 24. 24 will return to the called function. The called function is the main function and the value get printed. Okay, we will see an example in the code blocks. Okay, we will see programming logic. Okay, so here we are having a integer a. declare a variable. First hash include stdio.h is a header file. I'm declaring a function recf. RECF means recursive factorial. That's why shortly I'm giving a name recf. Integer is return type, integer recf, and integer is a parameter. It will take only one parameter, that is the integer. Here when it is this is known as a function prototype. In this place, the parameter name is optional. If you mention data type, that is more than sufficient. Okay. Inside the void, I have a main function, void main, it won't return a value. I'm declaring an integer variable, integer a. Okay. Using a printf statement, I display it in the output, enter a number. Okay. When a number got entered, it is stored in the variable a. Scanf %d is a format specified for an integer. It only 1% d is given. That means that scanf is going to get only one value. The value is stored in the memory address is address operator ampersand in the memory location of the a, and what will happen? I'm printing /n is a new line character. Factorial is %d. Okay, what will %d will do? It will call it is calling a function recf and passing the parameter. Here, what I'm doing in the print statement itself. Okay, I'm calling a function recf. I'm passing a value of the a. A is a foreign parameter. Actual parameter, that values get copied in the formal parameter integer x. Okay, the first time, okay, here the main is a called function, recf is a calling function. It will check x equal to 1. It will check x equal to 1. Okay, then we are, for example, we are having a value 4. 4 equal to 1. No, it will go to else part. F equal to, okay, 4 star recf of, okay, x minus 1 3. Okay, it will calculate. What will happen? The function now is calling itself again with a value of 3. Okay, this is the first recursive call. Okay, then what will happen? Okay, then it will call it's 3 into recf of, then I say 3 minus 1 2 will get stored in the f. And what will happen? Okay, here it is a next inner call. It will only become 2. Okay, 2 into recf of 2 minus 1, which is equal to 1. When x equal to 1, what will happen? Return the value. Okay, then 2 into 1. Okay, it will return the value of 2. Outer call 3 into 2, which is 6. Okay, 6 will be returned to the, okay, next outer call. Next outer call, I'm having a value 4. Okay, 4 into 6 equal to 24. Okay, 24, what will happen? If I give a 4 factorial means, okay, 24 will return to this place, okay, value. If I give a 4 factorial, it will print factorial of factorial is %d, 24 will get printed, okay. In this manner, we are able to calculate the factorial of the any number, okay. This manner we discussed. Okay, for example, for a simplicity, we can write like this. There is no need to store the value in the separate variable. We have to return the expression directly. So we can write a return statement here. It is also possible. Okay. Now I'm writing a return statement directly. Instead of storing result and returning a value, directly it will return the value. Okay, which we discussed, okay, in earlier example. Okay. Run the program. I'm entering a value of 4. The factorial is 24. Factorial value of 4 is 24. Okay. I'm giving now we will check another test case. I'm giving a value of 5, factorial of 5 equal to 120. Okay, that's it. For the previous lecture, we discussed what is recursion and what is recursive function and what is recursion, and we discussed about how to calculate the factorial, and we discussed about how to calculate the factorial using recursive function, and we saw step by step how the process are happen, and finally we discussed the program for this, and we check the program with the input. Okay, test cases input and the expected output are correct. Okay, that's it for this video lecture. Thanks for watching it.